To find the interval of convergence, I first check to make sure it's not geometric series. Since it's not geometric, I'm going to go ahead and use the ratio test. So the ratio test says that the nth plus 1 term divided by the nth term. And since I'm dividing by the nth term, I'm going to multiply by the reciprocal. So dividing these up so I can cancel them, notice that my n to the 9th are going to cancel and my x minus 3 to the nth are going to cancel. So I am left with this function. Okay, so this, as n goes to infinity, this gets closer and closer to n over 3 to n over 3. So this gets closer and closer to 1. Since x doesn't depend on n, I can just ignore this, and then this goes to 1. So I'm going to have x minus 3 to the 9th. And since we're using the ratio test, we know it converges when it's less than 1. So I'm going to have from negative 1 to 1, multiply 9 on both sides, and then add 3. So I get an interval of negative 6 to 12. Now I need to check the endpoints. You always check your endpoints from now on to make sure that if your endpoints are included or not included. So when x equals negative 6, if I substitute that into my series, so I'm substituting it here, I get negative 9. Okay, well that means that this is going to cancel, but I'm going to be left with a negative 1 because I can rewrite this as negative 1 to the nth over 9 to the nth. So this becomes an alternating series. So using the alternating series test, I need to check that the nth plus 1 term is smaller, which it is. And then I have to check whether the limit as n goes to infinity is equal to 0, which it is. So this converges, okay? And notice that the absolute value is a p-series that also converges. So this converges absolutely. Okay. Now when x equals to 12, if I substitute 12 back into my series, I'm substituting it for x. Now I'm going to get 9 to the n. So the 9 to the nth cancel. I'm left with a p-series with p equals to 3, so it converges. So this series converges on both n. So the interval of convergence is from negative 6 to 12, and you can write it in interval notations or inequalities.